Problem 18. An electric current of 8 ampere is divided into 3 branches forming parallel combination. The length of the wires in the branches are in the ratio 2:3:4 and the diameter in the ratio √8:√3:2. The wires are made of the same material. We are asked to calculate the current in the branches. First, let us see resistance of a metallic conductor is given as rho L by A. What is A? Area of the cross section. Area of cross section, we can write that as pi d squared by 4, where d is the diameter. So R proportional to L by d square. That is the starting point. Now let us find R1 is to R2 is to R3. L1 square by D1 square, L2 square by D2 square, L3 square by D3 square, which will come out to be 2 by 8 is to 3 by 9 is to 4 by 4, 1 by 4 is to 1 by 3 is to 1, otherwise it is 3, 4, 12. Taking LCM as 12, 3, 4, 12. This you remember. Now let us see the branching of current in a circuit. Suppose we have two resistances, say R1 and R2. So this is R1, this is R2. The current here is I. It branches as I1 and I2. In parallel connection, the potential difference is same. So what can we write now? I1 R1 equal to I2 R2. So I1 by I2 equal to R2 by R1. From this we can get I1 as R2 by R1 plus R2 times the main current I. In the same way, we can extend this to 3 resistances. In the case of 3 resistances, you will have one more branch which contains the current I3. So from here, we can have one more branch here, that is I3. The total current I is equal to I1 plus I2 plus I3. So I1 is given as R2 R3 divided by R1 R2 plus R2 R3 plus R3 R1 times the main current. In the cyclic permutation, we can get I2 and I3 in the similar manner. Now we are given I as 8 ampere and we got R1 is to R2 is to R3 as 3, 4, 12. So we can now find out this value R1 R2, the denominator, plus R2 R3 plus R3 R1 comes out to be 96. Substituting I1 equal to R2 R3 48 by 96 into 8. So that comes out to be 4 ampere. I2 will be, instead of the denominator is same, but now we will get R3 R1. So 36 by 96 into 8, 3 ampere, and I3 will be 1 ampere. So this is the shortcut method for solving the current. So the answer is 1, first choice, 4, 3, 1.